All right, so let's set the scene. Picture this. It's 1927, Brussels. You've got all the rock stars of science. We're talking Einstein, Schrödinger, Marie Curie, Niels Bohr, all of them, packed into one room. And they're not there to chat about the small stuff. No, they're there to figure out, well, the very nature of reality. And into this intellectual battleground steps a French prince, Louis de Broglie, with a new theory. And it's a beautiful one. It's elegant, it makes sense, and it looks like it could finally tame the wild beast that is quantum mechanics.
But here's the thing. By the time that conference wrapped up, de Broglie's amazing idea, the pilot wave theory, was totally dead in the water. And the way it died is what's so wild. It wasn't disproven, there was no killer experiment, no fatal flaw in the math. Nope. The titans of physics pretty much just voted it down. De Broglie's vision of how the universe works simply lost the popularity contest. And just like that, it was swept under the rug, forgotten for almost 100 years.
So for the next, 80 years, this whole idea was just a historical footnote, a little what if in the textbooks. But, and this is a big but, a recent experiment, and we are definitely going to get to that, hints that we might have made a massive, massive mistake. Which leads us to the central question, right? What if the theory we all just tossed aside, the one we collectively agreed to ignore, was actually the truth?
Okay, to really get why this was such a big deal, you have to understand the weirdest, most mind-bending experiment in all of physics, the double-slit experiment. The setup is pretty simple. You take a barrier with two little slits in it, and you fire tiny particles, like electrons, at it. Now, you'd expect them to act like tiny little bullets, right? Two piles on the other side. But that's not what happens. They create a wave pattern, as if each particle went through both slits at once. But here's where it gets really nuts. The second you try to watch which slit a particle goes through, the whole game changes. The wave pattern vanishes, and it starts acting like a normal particle again. It's like reality knows you're looking. It's this one experiment that made everyone think the universe is fundamentally spooky.
So this completely bizarre result basically started a war for the soul of physics. You had two main camps. In one corner, you've got Niels Bohr, championing what's called the Copenhagen interpretation. His take? Reality is just a game of chance. A particle isn't anywhere specific until you look at it. It's just this fog of probability. Then, in the other corner, you have Louis de Broglie with his pilot wave theory. He's saying, no, reality is real. The particle's always somewhere. We just can't see this hidden wave that's telling it where to go.
And what's so beautiful about de Broglie's idea is just how simple and intuitive it is. He basically said, hey, why are we forcing a choice here? Why does it have to be either a particle or a wave? What if it's both? He came up with this great analogy. Think of a surfer on the ocean. The surfer, that's your particle. It's a real thing in a real spot. But its path, that's determined by the wave it's riding on, the pilot wave. The surfer is literally being piloted by the wave. It just perfectly explains the double-slit weirdness without throwing reality out the window. It's no wonder Einstein was a huge fan. This is where his famous line, "God does not play dice," really comes from.
So you're probably thinking, if the idea was that good, why did it fail at the Solvay conference? Well, it turns out science is made by humans, and humans have personalities. Niels Bohr, he was a force of nature, charismatic, super persuasive, and aggressive debater. And he basically argued everyone into believing that looking for some hidden reality was just pointless. De Broglie, on the other hand, was this quiet, reserved, aristocratic guy. He just wasn't built for that kind of fight. So when the heavyweights of physics started pushing back, he kind of just folded. It wasn't just a battle of ideas, it was a battle of wills.
And so the hammer came down. The official verdict was that the pilot wave theory was superfluous. That's the word they used. All these unseen hidden variables just felt a little too much like magic. It seemed way easier for everyone to just throw up their hands and say, okay, the universe is random, rather than keep digging for some deeper layer we couldn't see. And the saddest part, even de Broglie eventually walked away from his own brilliant idea.
After that, the Copenhagen interpretation became gospel. It was the only acceptable way to think about quantum mechanics. For decades, literally decades, if you were a physics student and you had the guts to ask, but wait, what's actually happening? What's the particle really doing? You'd get the same answer over and over. Shut up and calculate. The message couldn't have been clearer. Stop asking philosophical questions about reality. The math works. Just do the math.
So after the theory was basically executed in 1927, it just went dark. But, a really good idea is tough to keep down. Fast forward to 1952. A physicist named David Bohm is digging around, and he finds de Broglie's old equations. He runs the numbers, And whoa, he realizes they work. They work perfectly. So he brings the theory back from the dead. But even then, it would be another 50 years, all the way to 2005, before the story takes its most incredible turn.
And you won't believe this, but the theory got silenced a second time. So David Bohm brings it back, and Einstein is over the moon. He's finally got someone else in his corner. But this is happening during the McCarthy era in the US, a really paranoid time. Bohm gets accused of being a communist. He gets blacklisted. He gets fired from his job at Princeton. He's forced to leave the country. And his science, his brilliant revival of this theory, gets completely ignored, all because of his politics. So once again, the idea is buried, not by evidence, but by pure human politics and bias.
So all of this leads to the ultimate question, doesn't it? For almost 100 years, this pilot wave was nothing more than a ghost in the equations. It was a cool idea, an abstract concept, but nobody, and I mean nobody, thought you could ever actually see one. But what if you could? What if you could actually make this hidden layer of reality visible?
The year is 2005. We're in a laboratory in Paris. Two researchers are about to try an experiment, and it's so beautifully simple, you'd never guess it was about to change, well, maybe everything.
Okay, check this out. These scientists, Yves Cooter and Emmanuel Fort, they take a tray of silicone oil and they start vibrating it at just the right frequency. Then they drop a single, tiny droplet of that same oil onto the surface. Now, instead of just merging back in, the droplet bounces, and every bounce creates these little circular waves, these ripples. And then, the magic happens. The droplet starts to move, pushed along by its own waves. It starts surfing on the wake it's creating. It literally became a macroscopic particle and its very own pilot wave.
So of course, they had to put it to the ultimate test, the double-slit experiment. They set up a little barrier and sent their surfing droplet towards it. The result was mind-blowing. The droplet itself, the little particle, it only went through one of the slits, just like you'd expect. But its wave went through both. And those waves interfered with each other on the other side, and that interference pattern guided the droplet. And where did the droplets land? They formed the exact same interference pattern that quantum mechanics predicts for an electron. I mean, it wasn't close. It was a perfect one-to-one match. This was the moment. I mean, this was the bombshell. It was de Broglie's surfer analogy playing out in real life, right in front of their eyes. For the very first time, we could actually see it happen. This little desktop experience showed, clear as day, that yes, a particle absolutely can be guided by a wave. And the implication is huge. Maybe all that quantum randomness isn't real. Maybe it's just an illusion because we've been blind to this deeper guiding reality the whole time. Now, let's be clear. This experiment hasn't settled the debate for good. Not everyone is convinced, and the arguments are still going strong. But no matter what, it teaches us something so important about how science works. For 80 years, the official story was that the universe is just fundamentally random and weird, and we should just accept it. This experiment whispers, maybe not. Maybe we were just looking at the problem all wrong. It's a powerful reminder that the most popular idea isn't always the right one.
And really, that's what we should all take away from this. Science is a human journey. It's messy, and sometimes it takes a wrong turn because of big personalities or politics, or just because one idea is easier than another. And if a theory as huge and fundamental as this one could be pushed into the shadows for nearly 100 years, well, it really makes you wonder, doesn't it? What other amazing truths are just sitting out there, forgotten on some dusty shelf, waiting for someone to come along and take another look?